In this tutorial, I will show you how to create histograms, and I will also go over the basic rules of calculating probabilities. The first worksheet you should be looking at is the histogram worksheet, which if you are not already on it, please click on the histogram tab. And then in order for this all to work, you need to install the Data Analysis Toolpack, which is free and already actually installed on your computer, but you sometimes have to enable it if it's not already enabled. And the way that you can know if it's already enabled is if you click on the Data tab up here, and you go to the far right, if it says Data Analysis here, it's already installed. If it's not there, what you want to do is go to File, Options, Add-ins, Manage Excel Add-ins, and click Go. And then make sure that Analysis Toolpack, not the Analysis Toolpack Visual Basic, but the Analysis Toolpack Basic, the General Analysis Toolpack, is checked, and click OK. In order to create histograms, the first step is to figure out what the bin size is. The bin size is the size of individual categories of the histogram. For example, if we have a histogram like this right here would be the midway point, and we would say that the midway point bar encompasses a certain number of points plus or minus the average. The next bar over would encompass a certain range on the x-axis, the next bar over another range. Over here, the next bar would be this range, and the next bar would be this range. And so we need to define these ranges for our histogram. And the way that we can do that is first by determining what is the minimum and the maximum of our data set, and then what's the difference in that data set. To do that, simply type with the minimum for distribution 1 equals min, and then select your data, which is A2 to A51. Equals for the maximum, max A2 to A51. So now we have the minimum and the maximum of our data set, and no matter that it's a negative number, that's perfectly fine. Data can be negative. Then you want to calculate the difference, which is very simply the maximum minus the minimum. And you get a total difference, a total span of the data set of 59.6. Now, in order to create a histogram, we have to decide how many bars we want. We could, for our histogram right here, have very large bars, or we could have very, very tiny bars that chunk up this histogram very finely. It really is dependent upon how variable your data set is. I recommend at least 20 different chunks or 20 different bins. So type bin size and equals the difference, the span of your data, divided by 20. And you get 2.98. Then we have to, under bins, figure out what all of the actual bins are. The first bin runs from negative 20.4, which is right here, and then the next jump up is going to equal negative 20.4 plus the bin size, which is 2.98. Now you could type E5 if you wanted to, but then you would have to lock E25 or E5 like that. And that's fine if you want to do that, or you could just type in 2.98. That works just as well. Drag this down until we get to the maximum of the data set, which is 39.2. We haven't gotten there yet. 39.2 is right there. These are our bin delineations. Once you have that, go to Data, Data Analysis, and then select Histogram. Click OK. Under Input Range, you will give the actual data, so A2 to A51. Under Bin Range, you tell Excel what the bins are that you just created, so B2 to B22. Create a chart output and put this into a new worksheet. Click OK. And this is the histogram that we get. And we can see that this histogram, although it is quite variable, we see some dips, we see some highs, it does look that it is approximately normally distributed. It's got that bell shape-ish to it. It's not great, but it looks better than maybe something that looks like this. There we have one histogram. Let's do the other histograms. Let's do the other histograms. We calculate the minimum for distribution 2, the maximum for distribution 2, the difference for distribution 2, the bin size for distribution 2, and again, we're going to do 20 different bins. And then under bins, our first lowest point is 5.8, and the next point is going to be this 5.8 plus the bin size of 68.37. And then we scroll this down until we get to the maximum bin size of 1373.2. Once again, go to Data Analysis, select Histogram, click OK, and the input range is going to be the data, G2 to G51, the bin range, H2 to H22, and then make sure Chart Output is clicked, press OK. And here we can see that this data definitely does not follow a normal histogram. Instead, it follows something that looks more like this. Let's try distribution 3. Once again, the minimum is going to be min. The maximum is going to be max. The difference is equal to the maximum minus the minimum. And the bin size, once again, if we do 20 bins, the difference divided by 20. The first bin starts at 2.3, and we continually add the previous value plus the bin size, which is 1.435. Let's roll this down until we get to the maximum bin, which is 31. Data analysis, histogram. Let's change this from G2 to G51 to M2 to M51. The bin range will now be N2 to N22. And once again, let's put this in chart output into a new worksheet. And here we see slightly better. Okay, it looks like it's about normal except for this long tail right here. That's okay. Last one, guys, the histogram worksheet. I don't know what this is doing here. We'll just call it 0.9. whatever it was in your worksheet. Not sure why it's different on mine. Minimum, we'll say min. Maximum, max. We have 0 and 1. All right, this is oftentimes what we would see in a percentage distribution. The difference is 1, or 1 minus 0. The bin size is equal to 1 divided by 20. The lowest bin is 0, and then equals the previous bin plus 0.05. Now we're going to roll that down until it hits 1. Let's go ahead and do the histogram, data analysis, histogram. Let's change that to S2 to S51, and the bin range to at T2 to T22. Click OK. And here we can see we have the opposite of what we've been seeing before, that instead of it being skewed to the left, now we are skewed to the right. Great job if you've gotten that far. You have some expertise in making histograms now and showing how your data look distributed. Let's go to the probabilities worksheet. And in this worksheet, I've given you some theoretical data on butterflies and whether they land on yellow, blue, purple, or red flowers in fields 1, 2, fields 1, 2, 3, and 4. Let's go ahead and just count the number of yellow flowers in field 1. And the way that we can do that is we type equals count if the range, which is this up here, B2 to B21, and then we type in quotations yellow. End quotations. There are 6 yellow flowers. Okay, let's copy that and move that over, over, and over. We're just copying and pasting the same function. And as you can see, what it's doing is it's moving the reference cells over as we copy and paste it. Let's go ahead and do it for blue. Count if, and then we'll type in quotations blue. We get 3. Let's move it over. For purple, count if purple, and move that over like this. And then lastly, red, count if red, in quotation marks, copy and paste it over. Now, down here, I'm asking you to calculate the probability that a butterfly lands on a yellow flower for fields 1, 2, 3, and 4. And the way that we can do that is we know that there are 20 flowers in each field, and then their butterflies landed on 6 yellow flowers of those 20. So we know that the sum of all of these must be equal to 20, right? Because there were 20 flowers in each field. If that were the case, what is the probability that a butterfly lands on a yellow flower in field 1? Well, it's merely 6 divided by 20. So equals 6 divided by 20. In the next one, 7 divided by 20. In the next one, 4 divided by 20. And in the next one, 6 divided by 20. What is the probability that the butterfly lands on a yellow flower in all 4 fields? Well, what we're asking is, what is the probability that a butterfly lands on a yellow flower in field 1 and in field 2 and in field 3 and in field 4? And if you remember our laws of probability, we multiply for and. So let's do that. Is equal to 0.3 times 0.35 times 0.2 times 0.3. And you should get 0.0063. You could also do this as product and then just select all of these values. And you will get the same number. Let's do this for the blue. Okay, we have 3, 2, 1, and 3. Okay, equals 3 divided by 20, equals 2 divided by 20, equals 1 divided by 20, equals 3 divided by 20. What is the probability that the butterfly lands on a blue flower in all 4 fields? Once again, product. So we're multiplying all of them together, all of these. What about for purple? Well, to save me from scrolling, I have 7, 5, 7, and 6 equals 7 divided by 20 equals 5 divided by 20 equals 7 divided by 20 equals 6 divided by 20 equals product of all of these numbers. What is for the probability for reds? Let's go up again. We have 4, 6, 8, and 5 equals 4 divided by 20 equals 6 divided by 20 equals 8 divided by 20 equals 5 divided by 20 equals product of all of those numbers. And that is the exercise, guys. That's all I have to tell you for this Excel worksheet.